This is a demonstration of 41446. I've just spoken with the customer and explained that the item is not failing. And what we're going to do is show you that it's not failing. And the way we're going to do this is by monitoring the output of your amplifier. By the way, that's your amplifier taken apart. I've actually gone inside, flexed the circuit boards, looked for loose connections. The item is not failing at this time. So what we're going to do is play a test tone through this, and we're going to monitor the output of this on this device here, which is called a dual trace oscilloscope. The upper horizontal trace is going to be the left channel. The lower one is the right. And your item is actually on right now. And as you can see, the left channel, the upper display, and the right channel, lower display, are producing no noise whatsoever. And I hear no noise, but the oscilloscope is a much more sensitive device than my ears. There's actually nothing occurring there. So what we're going to do is increase the volume, and at some point I'm going to have to switch the speakers off because it's going to get so loud it will hurt my ears and damage the speakers. And we're actually going to switch into what's called a dummy load, which puts the same amount of stress on the amplifier but does not create the audio energy into sound. It creates it into heat. And that is another tool used in testing an amplifier. So let's see if we can get this a little bit level. There we go. So I'm going to increase the audio now. Hang on. And I need to switch, make some switches here. You can probably hear that. And I'm going to increase the audio more. And again, as I get louder, I'm going to have to go into dummy loads where I will hurt my ears. Okay, so we're going to increase this. And again, notice that the left channel and the right channel are identical. Okay, now I've just switched into dummy loads, and I don't want to run this up too high because we can damage my dummy loads and damage everything here. But that is a tremendous amount of power right there. Absolutely, left channel, right channel are identical. I'm going to back it down again to nothing, and you'll see on the oscilloscope that there's absolutely no intermittent static, and the left channel and the right channel are identical. So I'm going to pause this now, reassemble the item, and test it assembled. Okay, we've reassembled the item, and we're going to back this out just to start at the same place we started initially. I could have done the front view, but we tested it initially with the rear view, so we're going to continue this test with the rear view. It's all been reassembled. I flexed the boards, no problems, and the item is actually on right now. And as you can see, and we'll see even closer, the left channel is the upper display, the right channel is the lower display. They are identical, and there was absolutely zero static, noise, or anything extraneous. I will now increase the amplitude, and we're going to see sine wave, and we're going to turn it up like we did before and go to our dummy loads, but your item is not exhibiting any problems. So let's turn this down a little bit. Okay, I'll turn the speakers on. And here we go. At this point, I'm switching into dummy loads. We're going to shift gears and keep turning the power up. Again, left channel is the upper trace, right channel is the lower trace. This item is not exhibiting any problems whatsoever. Here comes the speakers again, probably going to be loud. I'll back it down to absolutely nothing. Turn up the gain. There we are. Left channel and right channel are identical. Identical, zero noise, zero distortion. This item is exhibiting no problems at all. I'm going to email this up to you, Mr. Khan, and we're going to move on. Your problem, if it does exist, is not exhibiting itself at this time at this machine. It may be in a preamp or something else that you're using in your system, but this item is not failing at this time.